Hi, Wheat North Geology students. Today we're going to talk about weathering and erosion. Alright, so first, what's the difference between these two things, or two terms? They are different. A lot of people think they're the same thing, but weathering is involving the physical and chemical alteration of a surface. Okay, so this is the actual wearing down of the sediment. So when we're talking about in geology, rock surfaces, we're going to be talking about it being worn down. Now, erosion, on the other hand, is the actual movement of those weathered materials. So erosion is taking that weathered material and having it being transported from one place to a different place where it then typically is going to be deposited. Okay, so there is a difference between weathering and erosion, so make sure you have those straight. Okay, now let's focus on weathering first. There are a couple different kinds of weathering. The first one is physical weathering, and what physical weathering is the actual breakdown of the rocks, the physical breakdown of the rocks on Earth's surface. Okay, so you can think of it as the rocks disintegrating. Now this is typically a slow process over time, but we're breaking from larger particles down into smaller particles. There are a couple different types of physical weathering, or common ones, that we'll be addressing in this class. One that is a very powerful one is called frost wedging. Now, frost wedging is when water, liquid water, gets into some small cracks or crevices in a rock, and when it freezes, okay, water is one of those weird substances that its density decreases when it becomes a solid, so it actually gets a little bit larger, which is why it floats. But as a result, when it freezes, its volume increases, and then that breaks rocks apart. Now, you guys have probably experienced this as a driver, maybe without knowing it, but potholes. Okay, potholes are the same essential effect as frost wedging. So the water gets into the cracks, and then when it freezes, it expands and it breaks that pavement apart. And then that cycle kind of continues on. So that's why in the Chicagoland area, we end up having lots of potholes, because in our region, we get a lot of freeze-thaw cycles where it's constantly going through there. So in nature, that same exact process happens. But again, it's physically breaking those rocks apart. So this happens a lot, obviously, in mountainous regions. Okay, so here's a picture of showing how a big boulder can be broken apart. So very powerful. Another one for physical type of weathering is organic activity. Okay, so plant roots, animals, they do have an effect, and they break rock and sediment into smaller and smaller pieces. Okay, so you could think of it as, rock weathering and breaking down into sand, but you also have to think too, it could be talking about really tiny particles getting broken down even further into silt and clay sized particles. So physical weathering is going to involve all kinds of different sizes of material. Okay, the other type, so that was physical weathering. The other type is chemical weathering. Now, chemical weathering is the actual chemical alteration of rocks on the Earth's surface. So there's a chemical process. So you guys all went through chemistry at one point, and you guys remember, we talked about those different types of reactions: single replacement, double replacement, all those things, decomposition, right? But that parent material is breaking down into other different products from what its original state. Okay, so just like in chemistry class, we have the formation of a solution, an aqueous solution, if you will, because what we're doing is we're taking a solute, in this case a rock, and it's being dissolved by a solvent, which in our case is typically going to be water. Okay, so here's an example of that, and this is covering something that we've already discussed in class, and that is karst topography. So remember, karst topography is where you have a thick layer of soluble material that can be dissolved. So the limestone typically is what we're going to be dealing with in geology, is getting dissolved away, chemically weathered by water. Okay, and then we get the formation of caves and sinkholes as a result of that. Okay, so here's a picture showing that process up on the surface. Okay, so this is a slow chemical breakdown of the rock. Another type of chemical weathering is oxidation. Okay, now oxidation is when these rocks react with the oxygen in the atmosphere. Okay, so you're going to find this in rocks where iron is present, obviously, so the water reacts with the iron to cause this oxidation. So geologically, this is very important for us because we actually use this kind of process to be able to figure out or determine when we started to have a significant amount of oxygen in the Earth's atmosphere, because there was a period of time where the rocks, we didn't see any of this oxidation occurring, and then there is a definite range in the Earth's sediment layers where all of a sudden we start to see rocks oxidize. Okay, so we see this kind of like rusting starting to occur. And that was a sign for scientists that's giving us kind of a time frame of when there was enough oxygen in the atmosphere to cause this to occur. Okay, so that's another example of chemical weathering. Okay, now there are some factors that will affect the rate in terms of how quickly this process will occur. Okay, one of them is temperature. So high temperature is going to cause something to dissolve more quickly, right? The addition of liquids or moisture, that is obviously going to have an impact as well. Okay, the type of material. Okay, so is it granite? Well, that's not going to be chemically weathered. Okay, maybe physically weathered, but not chemically. Okay, and then lastly, the surface area. Okay, so think about, if you want to dissolve a chunk of sugar or a chunk of salt, right? You can break it into smaller pieces. So the smaller the pieces are, the quicker it's going to weather away or break down. So we can kind of group these into two groups. The first two with temperature and moisture, we can call that the climate, right? So the climate that exists in a location is going to impact how quickly something will weather away. Okay, and then the second thing, we can kind of clump those two ideas together and call it composition, right? So what the rock is made of and what its physical characteristics actually are. So climate and composition are the two big factors that are going to influence how quickly something weathers. Okay, so as an example, right, you think about a tropical jungle environment where there's a lot of moisture and high temperatures, you're going to see a lot of weathering occurring. Okay, so a nice example there. All right, so let's move on to erosion. So if we're looking at what causes erosion, there's really four factors: wind, water, glaciers, and gravity. Now we're not really going to talk about glaciers because we talked about that, or we discussed that in our last unit, right? But they obviously are a very powerful force in terms of moving material. Gravity we'll come back to in a couple of I think maybe the next lecture, we're going to start talking about mass wasting. But gravity obviously is going to have an influence on moving material. But what we're going to focus on right now is the wind and the water. Okay, so wind erosion, we typically call that abrasion. Okay, and that's where, just like a sandblaster, right, the wind over time is taking little tiny particles, and as the wind blows them, they can have a weathering effect on the surface. So we see a lot of this in desert environments in the southwestern United States, right, where it's dry, and then you get strong winds. So that's how we get the formations of beautiful formations like you see here in this picture. Okay, so as the wind just blowing material off the surface, so not just affecting features that are already being etched by the sand particles, but just the removal of material by sand, or by wind, I'm sorry, that can occur. Okay, now when we go to water, there's a couple different things that we'll talk about here. One of them is tides, right? So in this image here, you can see the tide coming in, the tide coming out. Now that repeats, twice a day for hundreds and thousands of years. That's going to have an impact on the material. Okay, so the material gets weathered away, and then the tides are going to carry. Remember, we're talking about erosion. It's the movement of material. It's going to carry that material away. Okay, so here's a picture of the tides, coming in and coming out. Okay, waves. Okay, so wave action. So as the waves pound and work their have their effect on the shoreline, right? The waves are obviously going to carry material away and affect the shoreline. Okay, and another one that occurs is called longshore current. Now, longshore current, if you don't have a lot of experience by beaches or bodies of water, you may be not familiar with this, but this is something that someone who lives in a beach area is very familiar with. Okay, so longshore current is just the movement of material parallel to the shoreline. Okay, so the sand and the gravel gets moved along. So you can see this animation is showing here the water, okay, the current flowing from left to right, and as that occurs, it's going to carry or push the sand in that same direction, because the waves come onto shore and off the shore and on the shore and off the shore, and as they do that, they're moving that sand material. Now, why is that important on the shoreline? Because if you're a landowner and you or a municipality, right, and you want to keep your nice great beach with all your sand, right, and then your neighbor builds a house or someone builds a house next to you, we don't want the sand from our beach to go down to his beach, right? So if the longshore current is carrying the sand material that direction, we want to preserve and keep the sand at our beach so we can take our family out there and enjoy it, right? So when you see pictures or a lot of shorelines, you'll see these things shooting out. They're called groins, kind of an unfortunate name for them. But what they're actually doing here is, if you can see, is they're preventing that sand from moving down the shoreline. Okay, so groins are built on shorelines to try to prevent the beaches from eroding away. Okay, so that's what those things are. Another type of shoreline erosion is called rip currents. So you might have heard of these before. So these are narrow currents that flow out to sea. And you can think of it like underneath the water, it's kind of a low spot. So the water comes up and all the water then pulls out through that channel. Okay, now these are tremendously dangerous. Okay, every summer kids in the Chicago area and northwest Indiana, usually there's a death involved of someone drowning because of rip current. Because what happens is someone gets stuck in this rip current, the water flows, and you can see this animation, they get pulled out, and the natural instinct is to swim back to shore, right? You see yourself floating farther and farther away, so people try to swim back to shore, but then they get tired, right? And then they end up drowning. Okay, so here's an actual picture. You can kind of see, sometimes they're tough to identify, but you'll see it's kind of may look like a space in between the waves. So that's an area you want to typically avoid. Now, if you do get stuck in one, there's a surefire way to save yourself, and that's to swim parallel to the shore. Okay, so if you're getting pulled out, don't try to swim back to shore. Swim sideways, swim parallel, because then that'll get you out of the rip current, and then you'll be able to safely make it back to shore. Okay, so a little bit of helpful safety information, beach safety information for you. Okay. All right, so that concludes our discussion about the difference between weathering and erosion. Make sure if you have any questions, you rewatch the video if needed, or obviously contact me.